In this video, we're going to take a look at functions, and the first thing we're going to start off with is we're going to look at a couple of situations. The first one is looking at these three soda machines, and we're going to figure out which one of these machines isn't functioning. So the first machine, button 1, gives me Coke. Button 2 gives me Dr. Pepper, and button 3 gives me water. And machine 2, we have button 1 giving water, button 2 giving Coke, and button 2 giving Dr. Pepper. Then we have machine 3, where button 1 gives Coke, button 2 gives Coke, and button 3 gives Dr. Pepper. So which of these three machines isn't functioning? So let's think about what that means. We have to think about different possibilities. Is it possible for there to be a machine that has multiple buttons that provide the same beverage? If you think about that, that's the situation that's marked in machine 3. We have a button 1 that gives Coke and a button 2 that gives Coke. Now, personally, I have seen this situation, right? If you go to a restaurant and they have a particularly popular drink, they might have multiple buttons on their fountain machine that provide that same beverage. So this is okay. Machine 1, each button provides a different beverage. So that also would work. But machine 2, something weird is happening. Button 1 gives us water, but button 2 gives us both Coke and Dr. Pepper. Is that possible? It is not possible. So machine number 2 is not functioning because the button 2, I guess I could say the 2 button, provides 2 beverages, and that's not possible. Okay, so we would say that machine number 2, is not functioning. Now let's consider the following semester grades for a Math 1332 class. Now, of course, these are fake. We follow FERPA, and there's no Mr. Pitt, Miss Barrymore, Mr. Pacino, especially at UCC. These are fake, but just to get the point across, let's look at these. So, Mr. Pitt has students Mike G, who gets an A, Andrew S, who gets a C, and Mike G, who gets an F. Miss Barrymore has a student Angela A, who gets an A, Carla V, who gets a C, and Teresa T, who gets a C. And then Mr. Pacino has Andrew Z, who gets an F, Mike G, who gets a B, and Cara V, who gets an A. And so which of these teachers, I'm putting it in quotes, you can't see it, but which of these teachers isn't functioning? So if you think about it, if Mike G is the same person in Mr. Pitt's class, is it possible for him to have a following semester grade that is an A and also receive an F? That is not possible. So which teacher isn't functioning? That's Mr. Pitt, because one student got 2 grades. In the 2 other situations with Miss Barrymore and Mr. Pacino, each distinct student gets their own specific grade. Now look here. It's possible that 2 different students could get the same grade, but it's not possible that one student get 2 separate grades. So this is the underlying meaning of what it means to be a function. So a function is where each input receives exactly one output. We call the inputs of a function the domain. And commonly, when we talk about ordered pairs, they correspond to the x values. The outputs are what happens to the inputs, and that gives us our range, and it corresponds to your y values. Oftentimes, you'll see mappings that look like this. X and Y, let's say 1, 2, 3, and let's call this 7, 12, 13. And as long as each input in the x's have exactly one arrow going to one value in the y outputs, we have a function. So I'm going to put a happy face. This is a yes. That is a function. It is okay if each of our inputs give us the exact same output. That's okay. That is a function as well. Each input has exactly one output. However, if we have one input that goes to two separate outputs, so essentially two arrows sprouting off of one of the inputs, then that is not a function. So let's look at a couple of examples and determine if they are functions or not. A function or not. The function is a set of ordered pairs. We have 0, 1, 2, 3, -4, 1, and 1, 2. So what you're looking for here is, are there any repeats? Because our coordinates are written x, y. What you're looking for, are there any repeats of our x's? So let's look at our x values. We have 0, 2, -4, and 1. Since there are no repeats, then this would represent a function. Now, a repeat would be okay if the repeat was the exact same ordered pair. But if we had 0, 1, and then later we had again in here 0, 1, that's okay. That's the same coordinate. However, if we had 0, 1, and then later on in our list we had 0, 7, that would imply not a function. But as it was written as our first example, yes, this is a function. The domain is going to be the set of all your x values. So that's going to be 0. Well, let me put them in order. So let's start over. In order from least to greatest, we'll have -4, 0, 1, and 2. Our range would be our y values. Now, notice our range is 1, 2, 3. There are only 3 values of the range because the value 1 gets repeated twice. So, again, their repeats in the y values are okay. Repeats in the x values are not okay unless they are exactly the same ordered pair. All right, let's look at another one. Function or not. We have the ordered pairs 2, 11, 4, 15, 3, 0, and 2, -2. So we want to look at our x values and see if there are any repeats. 2, 4, 3, and 2. So we have a repeat. So I'm going to put a little exclamation mark. We need to look at this closely because we have a repeat within our x values. So therefore, we have to look at their corresponding y values. If those two corresponding y values are the same, then it's fine. But since they are not, we have an 11 and we have a -2, that makes this not a function because we have an input that does not have exactly one output. This would be called a relation. It's still a relationship between two values, but it does not represent a function. So we would say this is not a function, but it is a relation. A relation can also have a domain and a range. So the domain in this relation would be our x values. So we have 2, 3, and 4. And the range would be the y values. So that would be -2, 0, 11, and 15. Now here's a clue that this is not a function. If your domain is smaller than your range, then that's a clue that something has doubled up. And therefore, we can assume that we don't have a function. That's when we're looking at these functions in terms of ordered pairs. So let's look at this one. We have the ordered pair 3, 9, 6, -5, 12, 0, and 3, 7. We have repeats in our x values. Their y values are different, so we can say this is not a function. But it would be a relation, and so we can still state what the domain is. The domain would be, the domain would be 3, 6, and 12. And the range is my y values, so that's 9, -5, 0, and 7. Now I'm going to put those in numerical order. In numerical order, it would be from least to greatest, -5, 0, 7, and 9. Now we're going to look at some examples of graphs and determine if it's a function or not. So one way that this might help us to see this originally is to write down what the coordinates are for each of these points. So for this first point, we have 1, 3. The x comes before the y. Here we have 3, 1. Here we have 4, 4. And here we have the coordinate 5, 2. Looking at this, there are no repeats in our x values, and so therefore, yes, this is a function. The domain of this function are our x values, which was 1, 3, 4, and 5, and our range on this one would be our y values, 1, 2, 3, and 4. So this represents a function. The next example, we have the coordinates 1, 1, 1, 3, 2, 5, and 5, 2. And hopefully you're now screaming at the screen, Anna, clearly we don't have a function because we have a repeat of an x value with different y values. So this is not a function. However, it is a relation, so it still has a domain. The domain is 1, 2, and 5. And the range would be 1, 2, 3, and 5. Okay? So therefore, we don't have a function. But what makes this not a function? Well, if I look at this, here are my x values. And if I look here at the x value for 1, you can see that if I were to draw a vertical line going up and down, I know it's not perfect, but that these points hit that line twice. So for every x value in the domain, if we have a vertical line and the values, there are 2 points that hit that vertical line, then that shows us that we do not have a function. If every point in the x values hits that line, if it's a vertical line going across exactly once, then we would have a function. So looking back at the previous example, let's look at our x values. At 1, we have 1 point that hits. Our next domain value is 3. Here, we have exactly 1 point that hits. At the domain value of 4, we actually have 1 point that hits, and at the domain value of 5, we have exactly 1 value that touches. So this is called the vertical line test. We use the vertical line test to test to see if something's a function. So if a function hits a vertical line going through exactly once, so I'm going to draw it going through like this, but you can use like a pencil or something to kind of drag over, and you can see that the function that I drew in red hits the lines that I drew in each of these exactly 1 time, okay? And so therefore, now notice those are arrows on the ends. The arrows indicate that it goes on forever, so this is not hitting twice, it's hitting once. But this vertical line test shows us when we have a function or when we don't have a function. So essentially, if at any point on a function in a graph, I can draw a vertical line and it hits 2 parts of that function or relation, if it hits 2 points, then it's not a function. We'll see a couple more examples of functions and looking at functions written as graphs and also written as equations in the next video. Thank you.